What does it really mean for an AI to think? Today, we're diving deep into system design, the critical path. Headline: Systems now determine market position. Every product is a distributed system. Scale amplifies design decisions into survival factors. Latency, consistency, and fault tolerance are not add ons, they are the architecture. The difference between growth and collapse is intentional system design. But here's where it gets interesting: the fragility of ad hoc growth. Headline: Incremental assembly produces brittle systems. Features accumulate. Architecture does not. Local optimizations create global coupling. Cascading failures become inevitable beyond a certain complexity point. Existing approaches treat system design as afterthought, not foundation. So, what's the real problem? Let's talk about the complexity multiplier. Headline: Complexity scales faster than organizational control. Each new service increases interaction surfaces non-linearly. Observability decays, mean time to resolution climbs. Knowledge gaps widen between design intent and operational reality. Without architectural discipline, entropy wins. This raises a critical question: the threshold of chaos. Headline: Unstructured complexity blocks all forward motion. Below the threshold, teams ship quickly. Above it, every change is a negotiation with invisible dependencies. Velocity collapses. Incidents dominate, trust erodes. This is not a resource problem. It is a structure problem. Now let's zoom in on first principles. Design from contracts. Headline: System design begins with explicit boundaries. Define interfaces before implementations. Treat every component as a capability contract. Isolation, idempotence, and backpressure are non-negotiable primitives. Architecture is the mechanism that decouples scale from fragility. Here's something most people overlook: the layered architecture model. Headline: Separate concerns by operational responsibility. Edge layer, authentication, rate limiting, traffic routing. Service mesh, inter-service communication, resilience, encryption. Domain layer, business logic, state machines, invariance. Data plane, consistency, partitioning, replication. Think about this for a second. Core primitives. Headline: Every scalable system assembles from 5 primitives: API gateway contract enforcement, versioning, message broker, async decoupling, delivery guarantees, workflow engine saga orchestration, compensation, state store event sourcing, materialized views, telemetry pipeline metrics, traces, logs. And this is where things get complex. The operational workflow. Headline: Design the flow before coding the services. Event-driven orchestration via durable logs. Every mutation is an event. Every service replays deterministically. Graceful degradation patterns. Circuit breakers, bulkheads, timeouts. Deployment rolling topology update with zero downtime contracts. But here's where it gets interesting: measurable impact. Headline: Intentional design yields predictable outcomes. P99 latency stabilized under load via backpressure architecture. Incident frequency drops 80% through blast radius containment. Feature velocity increases because components are independently deployable. Compliance becomes continuous validation of architectural invariance. So what's the real problem? Let's talk about self-designing systems. Headline: The next frontier is architecture that adapts. Feedback loops from operational telemetry inform topology. Machine intent contracts allow dynamic reconfiguration. Systems that observe their own behavior and adjust boundaries. The role shifts from designing systems to designing design systems.